Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 25, 2025, just over a week ago. It introduces a new reinforcement learning method that boosts code generation performance by a significant 4.4% on the Eval Plus benchmark. The paper is titled DiffuCoder, Understanding and Improving Mask Diffusion Models for Code Generation. And it offers some really deep insights into how these diffusion models actually work for coding tasks. The authors explore how these models can generate code non-sequentially and propose a novel training scheme to enhance this capability. Also, the authors shared their work on GitHub. If you're looking to try this out, you'll find their implementation of the new coupled-GRPO post-training method. They've included everything you need to get started, like scripts for data preparation and training, so you can really dig into the code yourself. On Hugging Face, you can find Apple's 7 billion parameter DiffuCoder models. The base, instruct, and fine-tuned weights are all available to download with usage examples. Okay, so to understand how they built those models we just talked about, this diagram shows the full training pipeline. It moves through 3 initial stages: adaptation, mid-training, and instruction tuning. But the key innovation is stage 4, which introduces their new reinforcement learning technique called coupled-GRPO. This method uses complementary masks on the code, ensuring every part is seen during training. This technique greatly reduces variance, which is like noise or uncertainty in the learning signal, making the process much more stable and efficient than traditional sampling. Alright, so this table really puts that new training method to the test. It lines up DiffuCoder against other models on standard coding benchmarks. You'll notice the colors: pink for autoregressive models, which generate code sequentially one piece at a time, and yellow for diffusion models like DiffuCoder, which can work on the whole code structure at once. Looking at the Instruct Model section, you can see the big impact of their new technique. Adding coupled-GRPO boosts the score by 4.4% on the Eval Plus benchmark, showing just how effective it is. So to understand how the model achieves that performance, these charts analyze its thinking process. They introduce a metric called autoregressiveness, or ARness, which measures how often the diffusion model acts like a traditional, sequential one. Looking at the plots, you can see global ARness is lower for code than for math. This suggests that when writing code, the model doesn't just go left to right. It plans more globally, jumping around to fill in different parts. This flexible, non-sequential strategy is exactly what makes it so powerful for coding. Building on that idea of autoregressiveness, these charts dig into the effect of something called sampling temperature. You can think of temperature as a creativity knob. A low temperature makes the model's outputs very safe and predictable, while a higher one encourages more variety. The plots on the left show that turning up the temperature makes the model think less sequentially. And on the right, the pass-it k-plots, which measure how often the model solves a coding problem within a few tries, show that higher temperatures actually lead to better overall performance. So to wrap things up, this work on DiffuCoder shows that masked diffusion models, which are models that generate code by filling in missing parts rather than just writing left to right, are uniquely suited for coding tasks. We saw that by increasing the sampling temperature, they can think more globally and creatively. And the new training method, coupled-GRPO, which uses a clever masking strategy to reduce learning noise, boosts performance by over 4%. This really highlights a new path for building more powerful code generators. That's all for this week's Roundup. Thanks for listening.